Hi, this is Khalid Jabber. I'm continuing with Chapter 1 actually. Chapter 1 is the Introduction to Software Engineering. This is Part 2. I already recorded Part 1, so this is Part 2. So I'm going to continue where I stopped in Part 1. So this is the last slide I covered in Part 1, and now I'm going to start covering Part 2. Part 2, we are continuing with covering the approaches that are used in software engineering. Kanban is also, it's another method actually, or an approach used in software engineering. This method is mainly if you have a process actually. Works good if you have a process or you have a workflow that something that goes through it. For example, here, okay, the tasks that needs to be done, they are visualized in a board in columns, and then the columns, it will represent the stages that something that has to go through here. I will explain more in details in the next slide here. And so let me go ahead to the next slide so that I can show the kind of how it works, and then I will get more into details about the Kanban. Kanban usually, as you see here, you see like this is a board. Okay, it's called a Kanban board. Okay, now this is for it's a process. Things that starts like this is the backlog. Okay, so this is where we have like the requirements that we need to develop. Like as you see here, like we have 3 requirements here. So there is like a phases that this requirement goes through, and we define those phases. The first one is called like to do. Like each column, it is a phase in the software in the process. So the first thing here, the requirement goes from backlog to do. When we move the requirement, for example, to the to do column, this means it is ready for somebody, for some of the engineers or the developers to take this ticket or take this requirement and start writing the code and etc. So when, for example, let's say that John is working in a team, and here there are 3 requirements. Okay, these are the 3 kind of requirements they pulled to, and they started working on them. So they moved it into in progress. So in here, while it wasn't to do, when someone picked up this requirement to start to write the code and develop it, they move it into the status. Okay, it's just like meaning the status. If you think of this as the status, okay, so the same thing, here the status, it's in backlog. Now when then it's ready to be developed. Now here when somebody starts working on it, the status changes, and then when the coding is done here, like for this one, there is one only ticket or one requirement here. It's finished the requirements on one card here. Okay, so the coding is done for this one here, so it's in testing. People they are testing, and then after that, when they finish the testing, they move it to done. So it's like a process flow. This is what is Kanban. If you have any software that or any things that needs to be developed where it goes through a process like that. Okay, so you use the Kanban. So Kanban mainly, a good example for Kanban here is it like for ticketing systems, like if, for example, okay, you are working a company, and the company, it solves, problems for the customers. So whenever a customer calls in and have an issue or a problem, you create the ticket, and then the ticket, it becomes ready. Okay, it's like in the to do column here. Okay, so it's ready for one of the people to work on it. Okay, so the other person is the person that when there is someone available to work on it, it moves from the to do to the in progress, and then when that person finishes working on it, it moves it to the testing, and then when the testing is done. If you have another example, okay, I'm spending more time in this one here just so when you make sure that you understand it. Let's just say that you have a business where you have plumbers, or you have a mechanic shop, okay, and you have many cars that needs to be fixed here. Okay, so while the cars are ready to be fixed, they are in the to-do section. Okay, when a mechanic is free, they will take the car inside and they work on it, and then when they work on it, it's in progress. So that car, is considered in progress. And then when they finish, working on it, they put it in testing, whereas the driver drives the car outside just to see if the car is working or not. And then after that, when it is done, okay, it moves to the done, and then they bring another car, etc. So this is how Kanban works. Okay. Okay, moving on. Another approach for software engineering called DevOps. DevOps here is that we write the code like as developers, but then after that there is an automated process. Okay, that the code quickly gets like compiled and debugged, etc., and then they're integrated into the system. And then DevOps takes it, runs the automation testing, it runs it, some automated testing. Okay, and then when everything passes, it goes and then uploads it into the production or into the field here. So there is an automation process for whenever the code is whenever the developers finish code and they want to deploy it. Okay, it goes through an automated process. So it is automated. Okay, process here. Okay, moving on. Okay, there's another approach is called rapid application development. This is also another approach in software engineering. Mainly here is that this is where is that it's like developing prototypes. Okay, so for example, customer wants you to write to develop a software for them, so they come to you and say, well, okay, this is I want the software to do this. So you take the requirement and then you go ahead and start writing code. But here you do not write all of the code. You just write enough code, small code, okay, just to show the user how this feature and how this requirement is going to look like, after they finish the software, you finish developing the software here. Okay, so the customer looks at that first prototype, they look at it and they need, well, I need more changes here, I need to fix this, etc. So based on that, okay, so the developer goes back and then rewrite the code and then add more to the code and then show the customer again. They look at the prototype, this is prototype 2, and then the procedure and the process continues going forward till it gets to the point where is that the customer is good, everything does good. So now that we start the developer goes and start writing more code, which is the actual full code to that needs to be developed here. So it's like so this is what's called the prototyping here. Another model which is called the spiral model. Spiral model, it works like you develop software in iterations, like iteration 1, iteration 2, etc., or cycle 1, cycle 2, cycle 3. Like for each cycle, you start planning the code, what you need to do. You need, I need to do this requirement, and then I need to do design and architecture, etc. And then also as part of the planning, as part of the iteration, you start analyzing about the risks. What are the risks that I may have in this iteration? And then after that, you will go ahead and then you do the engineering, and then you write the code, and then you develop it, and then you go back for the next iteration, etc. So spiral model, you are developing the code, and then also you are analyzing the risks that may you see in the software, may you see while you are developing the code here. I haven't seen it much. It's not much common actually. The most common approach is the agile approach here. So we don't want you to know much about this spiral model, okay, because this is not a common one that is currently used. Another one, this is an incremental model, which is part of the software engineering. This is mainly where you develop the software incrementally. So you start like, you pull requirements, you write the code, and you develop it, and then you put it in production, and then again you go back, and then you pull more requirements, and you develop it, etc. So incrementally, you are developing the software. Feature driven oriented, this is almost the same like the one which I covered before. It's mainly like when you develop feature by feature. So you develop the feature, you show it to the customer, everything looks good, and then you develop another feature, etc., etc. So the development here is based on feature it is based in developing features one after another. There is another one, which is another approach. It's called lean software development. This is very interesting and very good actually here. So whenever there is a process that has some waste, we call it waste, okay, we need to eliminate that. We need, for example, like if you are in a company, and let's take this example here, okay, like if you wanted to register a class in the university here, so the process and goes like that. You fill the application, okay, and you fill the form for the classes that you wanna take in that semester. You submit it, and then the registrar reviews the form, and then if you pay the money, etc. After that, whatever, okay, so they go ahead, they put you in the class, they register you for the class, etc. So if there is some type of repeated steps or something that you can eliminate going through the process here, okay, you should eliminate it. So mainly lean is mainly any process you work with. If there is anything that you can remove where you do not impact the process, something that is waste, something that is not okay, you shorten the time, etc. This is where is that lean is called here. Okay, so it's a continuous. It's a continuous. Okay, it's mainly, as I said earlier. Okay, this works with the processes and workflows. So you eliminate the steps that are not needed. Prototyping, we covered that as part of the rapid prototyping. Hybrid models is that where you can use more than one approach when you are developing your software the same. Maybe you use the waterfall, some part of the waterfall phases, some phases, and you use also like the agile. So it's like combining two models together. Or parts of them, not the whole model, maybe just a few parts of the models here. Okay. All right. Now the next topic here is that roles in software engineering. I'm not going to cover it in details here. So this is mainly who are working in the software engineering here. So it starts with developers, testers, business analysts. I'll leave this for you to read more, but these are some of the examples about for the people that were working in developing the software. Now moving on, this one, okay, this topic is trends in modern software engineering. So cloud computing, as you know now, this is one of the important topic and going on in the industry. There are some companies that they have a cloud, computing. Another one which is called microservices. Microservices is mainly you break the system into individual services, and these services they talk to each other through APIs, etc. Another one which is another attempt is DevOps, also continuing to become a growing kind of field or area in software engineering. AI and machine learning, security also, edge computing here. Edge computing is that developing software like for cars, real-time software, or for an airplane. So this is also remote teams. This is where is that people they work together remotely. They can use some tools, for example, Zoom, etc. PWAs. This one is mainly combining web and mobile applications together. Here is that you will develop like web applications that can run in using any browser, Firefox, Chrome, etc. So the software, the same code, it works for all of these browsers. And again, also the views, etc. It can work with all iPads and phones, etc. So you're writing the software that kind of generic enough that works with all of these in these environments here. Okay. Blockchain. Forget this is blockchain. This is not much important. This is a kind of a complicated subject. We're not going to cover that. Sustainability here is that mainly that this is writing light software. Okay, that saves in the energy. Okay, and this is, for example, is that you write the code that where you use less CPUs and less memory, so it saves in the energy. Observability and monitoring. So this is mainly an area where is that you develop software and tools to monitor, the performance, etc. Now, the last one here is the quantum computing. The quantum computing here is this is a future kind of developing a quantum. They call it machines. So the computers is going to be different than from the computers that we are using right now here, which means that the software engineering, the way we develop software, if we get into this quantum kind of machines, okay, it solves like the models may change and things may change here, but the quantum computing it will solve more complex problem that our computers cannot solve now. All right, now this is another topic, which is tools and technologies in software development. Okay, I'm not going to go through this. You can read this in your own here, but here mainly I'm listing tools that are used in software development, version control, IDEs, package managers, read, I mean, you can look at these, testing tools, project management tools. Again, also build automation tools, containerization. He's using Docker. Okay, Docker is a tool here actually, where it, to provide, okay, it packages the software into kind of things called containers, and that container, the whole application, puts it in a container, and it can run anywhere. It can run in your phone, it can run in a computer, in a laptop, etc., etc. Cloud platform, we talk, these are some of the tools. DevOps tools also I'm listing here, monitoring tools again, and then a database management system. So I'm listing some of these tools here. All right, security tools also, these are a list of some that I have some of them listed here. Front end tools, this is, you write the GUI interface mainly. Collaboration tools, people have to communicate, AI and machine learning, APIs and integration, code analysis, and then education tools. Okay, so as I said, don't focus much on this. This is just mainly I want to convey to you that, there are some certain tools are used in software engineering.